Hello and welcome to Let's Talk Robotics. I'm your host, Nikki Rousseau, and it's my absolute pleasure to be back for the first episode in 2025, and it's episode 165. We've had a long break, but we're back in the swing of things again. Robotics Australia Group has got a lot going on, and a big focus for the year is the release of the Robotics Roadmap for Australia and our inaugural Excellence in Robotics Awards night, and that's going to be held on the 20th of February in Melbourne. Tickets are moving fast, so make sure to book as soon as possible. And we, of course, have Minister Husick as our keynote speaker, so this is not a night to miss out on. Today, my guest is Brett Longhurst. He is the founding and managing director of Bremar Automation, a lean and flexible engineering design company specializing in the latest computer simulation techniques, including finite element analysis, multi-body dynamics, and design optimization. Bremar Automation is a network member of Robotics Australia Group. So welcome, Brett. I hope I got all of that right, and it's so great to see you again.
Hi, Nikki. Thanks for having me here. It's great to join in, and yeah, you went pretty close. You're 9 out of 10 on your.
Oh, excellent. And I always go,
Yeah.
oh, I've got something wrong. It's my
Yeah,
accent. I can get away with my accent, so you can correct me. So,
perfect.
so listen, Bremar Automation is, you're based in Melbourne,
Yep.
and you have been running this for 22 years. So tell us a little bit about your journey. I know you're going, how did I get here?
Yeah, when you add it up, it's surprised to think it's been that long. But yeah, I guess a bit of background. I'm an engineer through and through. As a kid, I pretty much loved anything with wheels. I'd draw cars, build Lego cars, and as I got older, brother and I had motorbikes and buggies and stuff, and it was just how we grew up, and it was just really in my blood, and kind of has never left, I think. So that kind of led me naturally towards an engineering degree. So I did mechanical engineering at Wollongong Uni, and then after that moved to Melbourne, managed to land a job at Holden as a traineeship at Holden, which was great, and pretty much spent 12 months at Holden in this traineeship program, learning CAD, computer-aided design, and all the, I guess, GM Holden vehicle design processes and that sort of stuff. So it was really good grounding for me as an engineer, and particularly on the technical side of the engineering things and where I wanted to go. So yeah, after traineeship, went into the CAD office within the powertrain division at Holden. So we were looking at engines and transmissions and drive lines, that sort of stuff, not so much the body side of things. And did a lot of CAD design work in the CAD group there for a couple of years, and then really I was always sort of angling to get into the analysis department there and focus on the simulation side of things, and managed to do that, and spent 5 or 6 years in the CAE group there, and really I think in hindsight was very lucky to have that portion to my career and that grounding, and has really sort of set the scene for where I've ended up as an engineer and how we do things as a business now. So that was great. And then, really after that point in time, decided to move on from Holden. We had some other things going on the side and bits moving around, so took the time to step away, and ended up basically, in short, taking all the bits that I loved about my job at Holden. There was plenty that I didn't love about it, but all the bits that I did love, and took that and really looked to build a business around it. So I freelanced for a few years just doing CAD and CAE work, and then added a grad engineer once there was too much work for me to do on my lonesome, and kind of grown it from there over the apparently 22 years. So
No, it's just a blink. Now, do you know Professor Gersal Aliki at Wollongong University? He's the head of department there.
I do not. When did I? So I would have graduated in '99.
Okay,
So
whenever.
maybe,
No, I think he probably came after, like it's not that long ago, but
yeah,
no, I think they've got one of the best engineering departments in the country, because I give them a plug out. I've spoken to him and they're very proud of it. But I think the graduates that leave there are really good engineers.
yeah, definitely. And we always had that experience. I think and even the Formula SAE team where the unis build a car and compete with those cars. Unfortunately, that I'd never had a chance to participate in that, but Wollongong was always one of the unis that was up at the top of that sort of program as well. So it was definitely great.
And what happened to your brother? Is he also an engineer?
He's no, he was more a trade, so he
Okay.
ended up fitter and machinist, and is now
No,
working in
I'm just
mines.
interested, the two brothers doing things. So
Yeah, he was definitely more on the practical side of things than I was, and better at making stuff and fixing stuff than I ever was. So
yeah.
it was good partnership, let's say.
And do you come from, is your dad or your mom an engineer?
No. Dad's a cabinet maker by trade,
Okay.
but certainly hands-on, and he always had an
Okay,
interest in
hands-on.
cars.
Okay, yeah,
Yeah,
that's it.
and always had an old car. He's got an old classic Mini that it's been in our family for forever, and always had an interest in cars. So I think that's probably part of it as well. So
Oh, so it's like an heirloom. You and your brother will be fighting over who gets this mini. I'll solve the issue. I'll take the mini.
yeah,
Like, let me just come and interject for you. So,
exactly. Yeah.
so how did you, was this just a natural evolution for you, that taking on one person that you decided, okay, now you're going to get a little bit bigger? Or did you go, okay, this is now my plan? And I always wonder, some things just happen, or it's 22 years later and you go, oh, how did this all happen?
Yeah, it's probably more the latter, to be honest.
Yeah,
And it's probably been I don't know, maybe a bit of a painful growth experience for me personally to kind of see where I've ended up. And the part of the irony was why I left Holden was that, I was kind of at the end of my technical career progression. I'd
yeah,
become quite specialized in what I was doing, which was fine, but it was kind of the same thing over and over again. Next step then was to move into, a supervisory management role, which my supervisor at the time was a few years ahead of me on the same career path, and he said, "Don't do it. You're gonna hate this."
mm,
So it's somewhat ironic, I suppose, that I left Holden because I didn't want to get into management, and now here I am. Basically, that's all I do is managing a small business and a team of people. But it's
listen, it's I speak from experience. It's not as, people think it's easy, but and I've got a couple of network members that have been CEOs and then have moved into chairs of their boards, and they've taken a step back from running the companies because you started and you think, oh, I'll just do it, but for some people it's just not a natural fit. They don't
yeah,
actually like telling people what to do. It's better to have someone else do that.
yeah, exactly. And as part of your previous question, no, I never kind of set out to plan to build a business doing this. I just wanted
Yeah.
to kind of do the stuff I enjoyed and not answer to anyone and be able to progress technically and do the stuff
Yeah.
that I love doing. And but it got to a point where when you're doing a business by yourself, by the time you do all the admin and the marketing and try and win the work and quote the work, and
Yeah.
you run out of time to actually do the work. But it's interesting in reflection that the next logical step is you put someone on to do the work, and you end up painting yourself into a corner where you're not actually doing the stuff you're good at or that you love doing anymore. You're running the
Yeah.
business. So it's been an interesting journey to reflect on that, I suppose, and to, I guess, even see and accept in myself that a big part of my job now is growing the team, managing the team, and enabling others to kind of have the experience that I had, in the early part of my career, and still try and get hands on the tools every now and then, but
Yeah.
do that in a way where I'm then able to pass on that knowledge to our team and our customers, and try and get a bit of the best of both worlds, I suppose.
I think you've described an engineer to a T. I just want to play with the things and just leave me alone.
Yeah, pretty much. Yeah,
Yeah,
put my
please leave me
headphones
alone. I'm not really interested in talking to you. I'm super smart, but I don't actually I just want to play and do my own stuff.
Yep, exactly right. And it's funny how that happens, and and where the sort of journey takes you, whether that's in a company of someone else's or starting your own. But it's certainly an engineer, that sort of introverted nature and the technical mindset doesn't always lead well to moving into those management roles. But it's certainly been
Yeah,
I would say, growth experience for me.
yeah. Just touching on the demise of the car manufacturing sector in Australia, which I think has just been awful, but obviously there are reasons around it. How do you think that's affected the industry and the flow on of all of this?
Yeah, look, I think it's been a big impact. It's such a good grounding or learning ground for young engineers and not just engineering, but manufacturing and the whole industry in general, and not just with the big companies, but all the suppliers that were feeding into that. So a lot of that, I think, knowledge has kind of been lost or dispersed. A lot of it's gone overseas, but at the same time, there's still a lot of it has stayed here. That the talent and the people who were doing that is still here and still in automotive. I think automotive, people think the industry's dead, but it's really just, certainly locally, has just changed now. There's a lot of aftermarket sort of accessories and the 4x4 industry and the caravan industry, and that has developed and I think elevated with, you know, people who have the experience at the larger manufacturers sort of feeding into those industries now. And there's also quite a big, I guess, sub industry of automotive where, you know, vehicle modification to suit, you know, not just to hot up a car to make it go faster, but now having to modify fleets of vehicles to suit, you know, a business purpose. You can't just go to a Toyota dealer or wherever and buy a vehicle that will do the job. Some of these things need to get modified, you know, wheelchair conversion cars, those sort of things. There's a whole, another industry sort of starting to emerge and grow within automotive now. So it's definitely there. It's just changing, and probably one other, you know, the importing and the right-hand drive conversions of some of the cars that are going on now is really, that's become quite a big business, and it's kind of a midway between what the industry used to be and having nothing. So it's there's still a lot of automotive stuff going on. People think it's gone, but it's just changing and evolving, I think.
I think that's brilliant. I'm delighted to actually hear it, because it's the skills and the smarts that are still in Australia, and we're very adaptive.
Yeah, oh, definitely. And it's just that, it becomes that sort of grit, small business mentality where you've got to be, and it was always the case at Holden. You know, it was interesting when we had engineers or we had teams or we had engagement with GM, the global company overseas, and they couldn't believe the sort of stuff that we were getting done there with such a small team of people and a small budget. And, you know, I think that's probably just an Australian mentality in itself, but certainly within automotive and where that's now flowing into other parts of the industry and other industries altogether. It's that sort of attitude of being able to punch above your weight is I think, a huge advantage.
Yeah, I think, and that's very typical of Australians, but also we've got this nasty little tall poppy syndrome thing that we're not going to touch on today, but it is prevalent, unfortunately.
Yeah,
but anyway, I don't know what it is. Like, you know, you want to actually celebrate for people who are doing well, because the spill on is, it could touch you. I always go, stand next to successful, smart people, because it will rub off on you.
Yep, I like it. Good theory, yeah.
I just move across them. I go, just rub on here. So listen, tell us a little bit about the work that you do at Bremar Automotion and the specialization.
Yeah, so I guess, still our business is really, the bread and butter is around the computer simulation stuff. So, you know, we talk about CAE being computer aided engineering. Most people know what CAD is in terms of computer aided design, where you're drawing the parts on the screen. But CAE is more around simulating the performance of those parts or systems. So one of the, I guess the main ones is FEA, or finite element analysis. That's a structural analysis. So we can take a CAD model that someone's drawn, and then we can put loads on it, put in some material properties, and see basically if the part's going to break or not at the simplest level. So really, there's other disciplines as well where we can, you know, the multi-body dynamics that you touched on, you know, we can build complex dynamic systems of a robot or a suspension system or a full vehicle, and you know, drive a vehicle around or put a robot through its motions virtually. So it's really about, you know, essentially you can think about CAE as being virtual prototyping. So rather than having to build a physical prototype and test it, we can do all that on the computer based purely off, you know, CAD designs, rather than having to actually manufacture something and test it. So, you know, the whole upshot of all that is that you save a lot of time and money being able to simulate things on the screen before going to physical prototyping and testing. In a lot of cases, it will give you a lot more insight. You can dig down and you know, extract loads or extract outputs out of a model that you couldn't actually do or you know, instrument up on a physical test. So there's a lot of advantages in doing that and being able to iterate quickly. Then it's not going to take you months to build a prototype, break it, build another one. You know, once your model's up and running, we can do that very quickly on the screen. And it's really, you know, become a mainstream part of particularly how bigger businesses do their product development cycle. And now we're starting to see that filter down to sort of SMEs as well. And really that's kind of where we look to position ourselves, in that we're bringing all our, a lot of people on our team have had that big company experience, and we try and use the big company experience and how to do things right and properly, and make that sort of technology and know-how available to SMEs and other businesses who don't necessarily need someone in-house all the time to do this sort of stuff. So
and can you give us some examples of your work?
Yes. So I guess, look, at a high level, we do a lot of 3D scanning work as well. So as a simple example, we could have taken parts where people have brought us a broken part. We can 3D scan those parts, put them back together in CAD, do an FEA on it, make sure we beef it up and make it stronger in some areas, and then we can get that manufactured as well, and that reverse engineering cycle. Right through to designing things from scratch. So, our automotive background is still very much core of what we do. So we are going through a program at the moment where we're designing a vehicle completely from scratch for a customer. Chassis, suspension. So we'll take, an engine, bits that we can find and source. We 3D scan all those, we put that all in CAD, we'll design the full system, make sure it all works together, and those sort of things. So in terms of, I guess, sort of robotic specific ones, robotics is an area that we're sort of relatively new at. We do have some customers in the field, but it's a new area. But where we're sort of able to provide, I think a lot of value here is around that virtual simulation. So we have had, a robot arm on a gantry that we've been able to model dynamically. We've been able to extract all the loads out of that. We've been able to design the gantry structure to meet those loads and make sure there's no vibration issues, those sort of things. We've been working with a company that does animatronic robots, let's say, for theme parks and movie sets. In a lot of cases, quite big structures. So again, we're able to simulate those before they build them, work out all the loads, make sure the thing's going to perform as they're intending it to, and not break. That's a really interesting field. And then, and I guess, a good example where we tie the two industries together, we've got a customer who does autonomous, basically robotic vehicles. So that's been a really interesting journey to watch that company grow. And we've gone from providing them consulting services and doing some FEA for them, to really helping advise their team. And now we sell them the software and train their people in how to use the software and be self-sufficient in doing that. But that's been
fantastic. That's such a good, and is it an Australian company?
It is, yeah. So they're
that's even better.
Yeah, it is. No, and they're going amazing. It's really been great to see, and it's really, we talk about automotive and robotics so far, and to see that come together in that sort of way, it's really cool. Cars in general are kind of becoming robots. Once as they're adding more EV and more systems and more controls and all that sort of stuff into it, it's almost becoming a robot that you're a passenger in now. Rather than the other. So.
And I think in the US there's more adoption. I think we've got a couple of hurdles here. For me, the biggest one, if something goes wrong, and I think this is partly why it hasn't moved as fast, is who's going to pay for it? Who's at fault? The insurance question. Like the insurance, this is paramount to anyone. If this electric or this vehicle bashes into autonomous vehicle, deviates, and I mean, we all know that there'll be less accidents on the road with autonomous vehicles, because I think they just drive better than most people do. But there will be deviations, and those deviations will cost. And, then, of course, everyone's going to throw up their hands and go, see, we told you. But it could be 1 in 2,000 as opposed to 20 in 2,000 accidents. People with their phone use today, it's appalling when you drive and you see people, oh my goodness, I just go, oh, there's another one on his phone. Can I take a photo? But I can't take a photo because then I'm on my phone. So I just who's monitoring these people? Find them.
Exactly, yeah. But I think there is certainly opportunities, and it's always hard when you're interacting with humans. I think it's humans in their own right are so unpredictable. It's hard. So I think there's certainly avenues. Completely autonomous vehicles, I think, on the roads are going to be still a long way down the track. I think there's probably going to be subsystems or maybe couple of blocks of CBD where it's just autonomous. I think there's potentially, there's a lot of talk on sort of long haul freeway driving where it's less it's a bit more predictable, I suppose. So, having, essentially a train of heavy vehicles or trucks that are autonomous that can drive from Melbourne to Brisbane non-stop, automatically sort of thing. There's probably more opportunity in that than just having blanket, autonomous cars driving around everywhere. But it'll be interesting to see where it all ends up. I think a lot of it's going to come down to, risk and regulation and who's prepared to sort of, put their finger up to take on the risk associated with all of that.
Yeah, and I also think, there's a whole parallel thing to it, that you need to redesign the roads as well. I don't know, our roads, they can't even handle cyclists, never, let alone autonomous vehicles. Like, let's just not get ahead of ourselves. So certainly in Melbourne, where we live, I was watching something on Current Affair about who's got right of way when you're in a bike lane. I actually had to take pause there and go, I would have assumed the cyclist did, but apparently if the bike track doesn't cross the intersection, then the vehicle's got the right of way. I don't know if you knew that, but I didn't know that. So I went, well, I just, maybe just watch out for the cyclists, because I think they're more vulnerable. So listen, you mentioned your team. So how many are there in your team at the moment?
6 of us full time.
Okay.
So we've got a good mix of capability. We've got myself, a couple of guys who are fully dedicated to the simulation side of things. We've got a couple of guys who are a bit more all-rounders, can do sort of the design, some of the physical stuff, some of the simulation as well. We've got an intern on at the moment who's working on 3D scanning and some of the 3D printing work for us as well. So, and Julie is our marketing coordinator as well, who's sort of helping us lift our game in that area of the business too. So, it's a great mix, great team, great culture. It really makes it a fun place to work. It's good.
Man, if anything like you, they're all flat out busy, because your day is just jam packed. Good luck to all of them. I think they're all working hard, but they would be enjoying it.
I think that is part of it. That's part of the appeal, as we've sort of touched on, a business this size is a bit of a double-edged sword, but there's trade-off both ways. But it's I think everyone enjoys their time here, and having an opportunity, I think, to see your involvement and your efforts, actually changing the business and growing the business and having an outcome, which you don't always get in a company.
Yeah, I think so. I've spoken to some roboticists over the years who've been involved in things, and they go, oh, I was involved in that. And you go, wow, that is something nice to be able to acknowledge and see that it's actually landed as something useful.
Yep, definitely.
So tell us, how's the industry developed and changed the last decade?
I guess we've sort of spoken about automotive, but if I sort of focus in a bit more on, the simulation industry in its own right, it really is a bit of a field of its own that can carry across any industry, really, whether that's robotics or automotive or aerospace, whatever. So, the simulation industry, I think, has certainly become more accepted, I think, and a bit more availability as well. It used to be, you go back 10 years and getting software or getting a computer to run it was expensive and a challenge. And there was always a bit of skepticism around the results and, that's all just computer stuff. We've got to do physical testing. And I think it's, over the years, it's become more accepted. I think part of the challenge is the fact that it is more available and a lot more accessible also means there's a lot more people doing things that, probably not the best way. And that's often just through lack of knowing any better. So we have seen from our customers who have had, analysis work done, and it's kind of just junk, or they've tried to do stuff themselves because they've, bought an add-on package to their CAD program. And, that's all good and well in a lot of instances, but you've got to kind of know where your limits are and where your software limits are. So we are seeing, still a bit of skepticism in the industry around, can we accept these results or not? And that's, sort of what we're trying to do is provide that, high level of analysis and simulation services, and also help educate our customers and our, industry contacts on, what to keep an eye out for a good simulation versus a bad simulation, because it's easy to get it wrong, I suppose.
So in terms of accuracy, what would you say is a percentage?
Look, it comes down to the type of simulation and how much effort you put into it. You know, it's a little bit of an 80-20 scenario where you can get probably an 80% close result with fairly minimal effort. But to get that last 20% of accuracy, you really got to put in a lot of time, make sure all your inputs and everything are right. It's the old, junk in, junk out sort of scenario. So we've spent, for us, we've spent a lot of time over the years doing physical testing and validating our computer models against. So, we are able to get quite complex simulations now down within sort of 5%
Oh, wow.
error. It just depends, what it is and really how much effort you can put into it. But
But that's any day an easier route to go than actually building it, being completely wrong, investing not only the time, the man hours, the hardware that you're wrong. So what would you say is percentage doing simulation like this to actually going and building something, a prototype that you go, this is completely not what it should be?
Yeah, look, the savings could be, orders of magnitude, really.
Yeah.
We've just done a program designing, it's called a falling object protection system for a fleet of forestry vehicles. So it's basically a canopy that goes out over the roof of the vehicle, protects against a tree strike or a branch strike on the vehicle. So, part of that was meeting an ISO standard. So we had developed the design of this FOPS using computer simulations. The ISO test required us to drop 227 kilos from about 5.5 meters.
Oh, wow.
So we had done our simulations on that, and we did a physical test and did that. But the physical test side of things, which we had to do anyway to tick the box for the ISO thing, but to go through that process, we had to build the prototype, we had to find an area to do it. We had all the health and safety stuff when you're dropping, a couple of 100 kilos from 5 meters. Had to hire a crane, all that stuff. So, that's a very expensive exercise. So to do the simulations was probably, a tenth of what that would cost. And in that instance, the design passed, did everything it needed to do and lined up really well with the simulations, which was great. But if you had to do that as purely just as a physical test and it didn't fail, or you had to iterate on that, that's a very expensive exercise. And so the other benefit of us doing that physical test is now that we've got confidence in the computer simulation. So we're now going to adapt that design of the FOPS to a different vehicle, a different style of vehicle. And because we've got the confidence there, the customer has the confidence, we can do that purely in simulation now. And that will be a fraction of the time, a tenth of the time that it took us the first time. But also if we had to do physical prototypes and physical tests every time, it's orders of magnitude, there's possibilities, I would say.
So is Bremar, you're obviously a specialist, or you sound as though you would be one of a handful in Australia?
Yeah, I think so. Yeah, there's probably, I think a lot of the capability at our level is within internal companies. So, particularly defence now, a lot of the guys I know that were in the industry at Ford and Holden and other places have been sucked into primes in the defence industry. So you can't go and ask them to do an analysis on your FOPS or on your robot arm. So I think, the companies around that are able to do, that have firstly our level of software and experience, but, also the physical testing to kind of back up the level of confidence. There's not many around that would be able to do it at our level, I would be pretty confident in saying,
Fantastic. Congratulations. We touched on your journey as a business manager. As an SME, what do you think, or what are your biggest challenges?
Look, there's a few. I think for our business personally, and it's and me personally as well, I think part of our challenge is awareness. We're great at what we do, but the challenge has always been letting people know we're here. Trying to explain and articulate what it is we do. We do quite a lot of stuff. So how do we kind of tailor that to what you actually need? And then how do we kind of, a lot of it is a bit jargony and a bit, hard to grasp at times what the concepts are. So sort of educating people on what we do, how that fits with what their business does or what they're trying to do, and how we can provide value and shortcut their development cycle and that sort of thing. So that's always been a bit of a challenge that we're slowly getting better at, but it's something we're always working on. I think, finding people is always a challenge. We've been very lucky over the years. I don't think we've ever actually advertised for a role on Seek or something like that. So we've got good networks. We always talk to people and customers and just people we know. I'm always happy to have a conversation with anyone who reaches out, and you just never know where that sort of stuff leads. We've had some good relationships with a couple of the unis, and picking up grad engineers and those sort of people out of there has been good. But at the same time, working in a small business like this is not everyone's cup of tea either. We've had people come from big businesses who look great on paper, but they just don't get the commercial realities of a small business like this. You don't have the luxury of sitting there and spending the next 6 months on this project that needs to be done in sort of 2 weeks for us to make money, or we can't do it, sort of thing. So there's always that. That's been a bit of a hard learning experience over the years as well, finding people who are passionate about what we do and what they're going to do in the business, and helping them grow and become the person they want to be and the career professional that they want to be as well. So and I think probably just the other one in general that we find, particularly here in Australia, is just regulatory red tape and hoops we have to jump through, and the costs and the time associated with all of that stuff. And it's a constant challenge. There always seems to be something new that you need to comply with, or that you need to fill out, or that you need to, get an accreditation for or something. And it's look, it is what it is. It's it's your ticket to ride in some respects, but it does make it hard to run a small business in this sort of climate when you're always having to comply with that.
It's very time consuming and resource consuming. Just on your point of view, explaining your value proposition, do you think it's also a question that industry and the market is now also matured more, that these type of simulations it's more acceptable, and people would go, well, why wouldn't you be doing it? It's like a bit like talking about robotics and adopting robotics. You go, but why wouldn't you do this? Number one, it's safe, it's secure, like you're saving money. What's what is the issue?
Yeah, look, it's probably just been a bit of skepticism, I think, and the more, particularly with our customer base, the more that we can show, these physical tests and how well we can get the simulation to line up. And I think there's also, a bit of an offshoot of people working in big companies like Ford and Holden, who have now dispersed into other industries and other businesses, who say, well, this is how we would do it. We should be doing this. And that's kind of grown a bit of the awareness and maybe the urgency around some of these technologies, and starting to, gain that acceptance. So, but it is, always a bit of a challenge. And I think, look, the other, like I touched on before, the fact that it is so easy to get bad simulation results. I think people are a little gun shy of that, and maybe have been burnt with bad simulation work before, or just not knowing what they're doing, or having someone work for them who maybe didn't know all the stuff that they needed to do. So I think all of that probably plays into that.
Yeah. I like your point about people coming from big companies, because I run a small company. Robotics Australia Group is a very small company. We lean and mean. Every time I have to spend money, I say to someone, don't you think you can give me a discount? Can you just not give it to me for nothing, please? We are not for profit, please. Just give it to me for nothing. I don't know why you're charging me, but, I have to say I went to a building in the city because I was meeting someone, and I was just sitting there waiting for them. And the amount of people that came out of the building at 10 o'clock strolling around for a coffee. I looked at them and I thought, listen, if you worked for me, I'm sorry to say, but you wouldn't be doing this. I'm telling you now, they're now strolling out here, chatting for a 20-minute coffee. Look, maybe corporates can afford this, but small SMEs, there's none of this rubbish. Like and I expect probably, it's not that you're watching your team with with like binoculars, what are they doing? But you're working. There's no sitting around and well, I can just earn money and not get do anything.
Exactly, and that's it. It is a hard thing to get your head around, particularly when you've come from that sort of big environment where there's no kind of accountability at some level. I look back at
Yeah.
the time I spent at Holden and how I spent my time, and
Yeah.
you know,
It's quite
you kind of
crazy.
wonder, how do these companies survive and make money? It's like if a big company like that was run with an SME mindset, and
Yeah.
look, it's probably not unlike the whole Tesla thing. That's kind of how
Yeah.
that thing's run, and you know, it's successful in its own right in various ways. But yeah, it is certainly, you can see how these companies get bloated and get slow and get, you know, uncompetitive in the marketplace. But yeah, I think it's just
Yeah.
the cycle
No,
of business, I suppose. Yeah.
no, it's a different mindset. Trust me. I look at it and I go, listen, like it just wouldn't work. But speaking of Tesla and Elon Musk, luckily we might as well tie in my little South African there. Not that he wants to be acknowledged as a South African, but I believe now with him being Donald Trump's sidekick, he's already gone in there and he's tried to fire some people, but apparently he cannot do it without Donald's say so. So I think that's hilarious.
Yeah, it's
I can see his mindset going in there. Half of you out the
yeah.
door. What
What
are
do you
you
want?
doing? Yeah, where are you walking around?
Exactly. Yeah, I think there's,
Uh,
to be honest, there's probably a comfortable middle ground, I think. But
yeah,
yeah, it'll be interesting to see what happens for sure.
yeah. Tell me, what highlights have you experienced and celebrated?
Um, Look, I think probably what, like I touched on before, the computer simulation and the physical correlation stuff is always a great satisfaction for us, but also our customers. I think it really paints the value of what we're doing, and they can really see the outcomes and the benefits of doing that sort of stuff. And we've done that, yeah, across a lot of different projects and a lot of different scales, from a simple little bench test in our factory here to, you know, instrumenting a truck and multi-trailer combination and driving that around a proving ground and being able to replicate that sort of thing. So that's something that, you know, I think our guys from a technical point of view get a real kick out of, but it also just cements, I think, the value in what we do. It's always good, and again, most of our team are really hands-on people. You know, it's really nice to be able to connect the physical and the digital sort of realms, and that was part of what I missed at Holden. You know, I'd sit and I'd design and analyze a part for months and months and never actually see the physical thing, or it would
Yeah,
turn up on my desk and you kind of like, oh, that's small. You know, you're so used to looking at it right up zoomed in these little areas. So you know,
that's what
I
I've spent the last 5 years, like the 5 years wasting my life.
So that's been good, and look, I think that probably leads into what the recent addition to our business is around the additive manufacturing
Yeah,
side of things. So we've got a set of industrial 3D printers now. We've
yeah,
moved from a little rickety prototype printer where we used to print just little rapid prototypes now to a point where we're able to produce, you know, high strength end use parts at
yeah,
scale, you know, up to sort of 400-500 millimeters cubed per part. So that's really been a new addition to our business in the last sort of 18 months. And that's been a real, I think, highlight for us, and has broadened our capability and again, has given us as a team of, you know, essentially CAD guys and computer designers a way to end up with a physical part in our hand that is not just a prototype anymore. We can
yeah.
put this on a vehicle, we can put this on a robot, and it's an actual part we can use. So that's been a real game changer for our business and our customers for the right application. And so, yeah, that's definitely been a highlight, and has built capability into our business and opened the doors to conversations we probably wouldn't have had in the past, and yeah, built some new networks and relationships through that as well.
Have you found parallels between the robotics and the automotive industries?
Yeah, look, I think there's obviously a technical aspect to it, which I think is very aligned. They're both, you know, there's a lot of thought and intricacy and quality and processes and procedures that need to be there. I think that the kind of mindset and the people who work in those industries are probably quite aligned in a lot of ways. You know, I think we've sort of touched on the labour challenge side of thing. I think that is an issue, both from the retaining good talent at the sort of you know, the engineering type level. I think also, and listening to some of your previous podcasts, I think other people have touched on it. Even at that technician level, though, it's hard to find and retain people to service and maintain, these machines, whether they're a robot or a car. It's particularly as cars start to progress into the EV side of things, there's a very specialized skill set now there that you need to go through the training. You need to be able to do that sort of stuff. Your mechanic down the street can't, deal with a 400 volt EV system anymore. So, and again, I think it's probably the same in the robotic space as well. But I think, yeah, certainly that, the side of the simulation, the acceptance there, we've seen that starting to grow there. And I think now, just going back to what I was saying with the vehicle industry changing and the volumes now, we're not building, 1 million cars a year anymore here. It's the volumes have come down. And so the leanness in the manufacturing mentality is probably applicable and relatable across both industries as well. And again, that's where we see a bit of an opportunity with the 3D printing and the additive manufacturing is you're no longer having to tool up and do castings in volumes of thousands and thousands. And we can make parts in volumes of 5 or 10 or 100 and do that at, minimal upfront cost. And that's happening. And we're doing that across automotive industries. And I think there's a parallel with that in the robotics side of things as well.
Yeah, that's fantastic. And why wouldn't you be doing it? I look at the SMEs in Australia and I just want to put my hand around them like a big plucky chook and just look after them. I think they've got such a raw deal. They work incredibly hard. They make up, is it 75% of the economy? Like, it's a huge number, and they normally one owners that just carry the can and employing, you 6 people that you're responsible for, that you're going, listen, maybe 6 of them have got families, it's not an easy journey.
No, it's not. And I think, again, from an automotive or robotics point of view, I think, there seems to be a bit of a lack of awareness or lack of understanding at that government level and regulatory level around some of the impacts of the decisions that are made. We've talked, even with our customers and within our industry groups around even opportunities for funding, government grants and those sort of things. Often we've had to pass up on a couple of grants because either the business is too small or you have to co-fund, in the order of sort of $500,000. There might be a $2 million grant, but you've got to come up with $1 million to win the grant. Businesses this size kind of get passed over. Our business could certainly benefit from a $20,000 grant or a $50,000 or $100,000 grant. That's a bit more accessible and tangible. We could co-contribute that level of funding, but when we're up at $500,000 or more, to buy equipment or upskill staff or develop capability, it's just not accessible for SMEs. And I think that's something that would really benefit and help. Have an SME sort of grant or fund or something that helps some of these sort of businesses get a bit of a kickstart on things they want to achieve, because it's hard to do without it, and it's hard to take your people away from paying work to try and win a grant or to develop a new capability when you just you need to focus on keeping the cash flow happening. So
touching on AI and cybersecurity in your business, I'm sure you're aware of it all. I think I've been to a couple of talks that people have said if you haven't adopted AI in your business, you've been left behind. What do you think, number one, what are your thoughts on it? And, again, for SMEs, do you think this is even something that crosses their mind, like the AI adoption and, we should be doing all of this thing? I certainly think cybersecurity is becoming more prevalent, and this is definitely something that is just your security around your systems and anything, because the last thing you need is to be hacked and your cobot goes berserk and does something that it shouldn't be doing. And that is actually something that people should be aware of.
Yeah, definitely. It's the cybersecurity stuff we haven't really had a lot of dealings with, but certainly AI is becoming a game changer, I think, across the board, really. We're using it, I suppose, the usual sort of chat GPT and the new, whatever the Microsoft one is called now.
Deep Sheet.
Yeah.
A bit of an unfortunate name. If you say that fast, you can get a little bit tongue-tied there, but it's Deep Sheet, I think.
But I think, look, there's a lot of benefits. It's, and again, it's, the little admin stuff or looking this up or, search stuff, I feel like it's better for that. The obvious kind of use cases. and even in some of the work we do from a coding point of view, I think it's enabled our engineers to do stuff that we couldn't do before. Just write a little code to extract this data or filter this data or whatever, that would have been the job of a coder, or we'd have to send that out and get someone to do that. We can kind of do that in-house now, which is really amazing. I think at the business level, there's opportunities. I think it's not quite there yet for small businesses, but I definitely see some opportunities for marketing and that side of things. That's always been a challenge for us. We've got so much cool content, images and videos of stuff that we do, but how do you put that into something that's an actual piece of marketing content that's engaging? And we know of a couple of companies around working in that space, and I think that's really going to open up some opportunities. Again, it's focused on the big end of town at the moment, but as that filters down to SMEs, I think being able to unlock some of the effort required to create good marketing content is going to be a game changer as well. And then within our software platform that we use, it's sort of grown. It's called Altair HyperWorks. It's grown from basically an engineering FEA package to this massive data manipulation and interrogation package. So there's ways now that rather than us build a simulation model and run that over and over again, which can be very time consuming, we can feed in data from physical testing and maybe some other simulations that we've already run, and instead of it having to run an analysis that might take 1, 2, 3 days to run, the AI can suck in all the data that we feed into it and make predictive analysis in a matter of seconds, sort of thing, without having to run days of simulation every time. So again, that's fairly new technology, but I think as it matures and becomes a bit more accessible and a bit better understood, there's going to be some huge benefits in that sort of thing.
There's actually the National AI Centre is running a day on AI manufacturing in Melbourne on the 20th of February. I don't know if you know about this. I was only actually made aware of it yesterday. But yeah, it's free to attend. It's from 11 to 2. So I'll send you the details for anyone listening to this. I hope I'll remember to put it in the show notes. But yes, that's running as a resource day, which should be quite interesting.
Yeah.
Where do you see the industry moving in the next 10 years?
Look, again, I suppose if we're talking across a couple of industries here, but or manufacturing in general, robotics, automotive, whatever that might be, I think certainly in our domain, I think the simulation stuff will continue to become more accepted, more accessible. I think it'll be easier to use. It's been the domain of like a dedicated analyst. You need someone like me who's had 10 years of experience to get some good results, and that's slowly being eroded away where you can get some good results from some fairly straightforward analysis. So I think that's going to continue to grow and evolve, and certainly within that simulation space as well. We kind of talk about multi-domain simulation. So at the moment we've got our FEA stress analysis, we've got our MBD system analysis, we've got say aerodynamic analysis. And they're kind of individual compartments. They don't really talk to each other much at the moment. It's starting to become a case where they talk to each other now, and I think that'll continue to grow. So you can put aerodynamic loads on part of a car or something, and then get the structural loads out of that and see how that then affects the suspension, and that will all happen in one simulation. So I think it's really exciting when you start projecting out where we're at, where we've come since I started in the field, and where that's going to end up and how much it's accelerating. So I think that sort of simulation stuff is going to continue to grow and become more accessible. I think we've touched on too the additive manufacturing again for us and our business and our customers. I think that's going to become more and more mainstream. It's still a bit of an education piece for us to tell our customers, hey, we can print you a part you can actually use now. We can print plastic parts that have carbon fibre in them that are as strong as aluminium now. We've got a metal printing system as well here. So, small complex parts that cost you a fortune to get CNC machined in low volumes, we can print those easily now and pretty cost effectively. So that sort of stuff, as awareness grows and again, the technology grows with it, I think that's going to be able to allow companies to tailor components or systems to suit a particular customer with ease, customization of cars or robots or whatever it might be. Robots are a good example, and with robotic grippers and end effectors and those sort of things that are made to suit or pick up a particular item. That can be done so much easier and cheaper now than it used to be able to with additive manufacturing. So I think that sort of stuff is is only going to grow from here. And we've talked about AI, but also some of the virtual reality and augmented reality tools as well, where we have a little bit of a touch on that sort of stuff, where we can take our CAD models now, and instead of just looking at it on a flat screen, we can put that in a VR headset and hold it in your hands and actually get a sense of size and scale and see how you could assemble it. And we've seen stuff where people are learning how to weld using virtual reality, that sort of stuff. It's all that stuff. It's just becoming so much more accessible now, and people are seeing the value in it. It's gone beyond just being a cool gimmicky thing at a trade show now to actually being able to educate and train people using those sort of technologies. So all that stuff combined, I think, is really exciting to see where things are going to be.
Yeah, and I think the important point is that people need the information. They need to know it's out there. The youngsters, especially, there was a period of people going, oh, all these robots are going to take over. I go, listen, if you know the capability of this, it's simply not true. It's assistive technology. Great if a robot can take dirty laundry in an aged care facility, in a hospital. Who wants to be doing that? I think the focus for robotics and the use of it is going to come from a safety perspective, that you go, why wouldn't you be deploying a robot here? If a human did this and something went wrong, there could be a fatality. It's a good reason to use a robot.
100%. And, we talked about autonomous cars before. And I think the use case in reality is not going to be, self-driving cars in urban streets. I think, or that's a long way off. But, you look at applications for self-driving mining trucks and, dangerous environments like that, factories and those sort of facilities where, those sort of self-driving mechanisms make so much more sense, and the safety factor involved in that, is a huge part of it. I think if you can remove, dirty, unclean, dangerous jobs, then why wouldn't you? Whether that's through an autonomous vehicle or a robot or whatever, it just makes so much more sense. No one wants to do those jobs these days anyway. You're having to pay someone $150,000 a year to drive a mining truck because no one wants to do it. So there's cost benefits, I think, to the businesses as well, and from a labour point of view, particularly here in Australia. So I think there's a lot of upside to it.
I think most mining trucks on big sites are anyway autonomous, from what I understand. And mine, the big mines just don't talk about it because, that's not their business. Mining is their business. How they do it is none of our business. It's just the by the way side. Exactly. Of course, I want to know all about it. So. Brett, I'm mindful of your time. Have you got any closing thoughts that you'd like to leave our audience with?
No, look, I think we've probably touched on a lot of it. I think, certainly if anyone wants to know or is curious about the simulation side of things, what can be done, whether that's aligned to robotic applications or otherwise. Same with the 3D printing and additive manufacturing stuff. I'm all about having discussions and meeting people and talking to them, showing them what we can do and understanding what they do and how we can maybe work together. So I guess, if anyone's curious or wants to know more, please by all means just reach out. And I'd again just like to thank you for the opportunity to come on here and have a chat. It's been a pleasure, and look forward to working together more.
Oh, it's fantastic. Thank you. And thank you for your support being a network member of Robotics Australia Group. It's our network members that keep us sustainable on my mean and lean budget. So I'll have to throw that in there. To our audience, you've got an invitation now. Brett has invited you. Follow him on LinkedIn. And what's the best email address, Brett?
It's Brett, BRETT, at Bremar Auto. That's BREMARAUTO.com.
Okay, I'll put that in the show notes as well. So anyway, you've all got an invitation. I'll reach out to him. He'd be delighted to hear from you. Brett, thank you so much for your time. It's been an absolute treat talking to you.
Wonderful. Thanks, Nikki.
Thank you. And to our audience, thank you so much for joining me again. I look forward to your company next time. Be well wherever you are in the world.